All right, all right, all right. So we've got ourselves another wonderful proof here. And we got another property, a new property actually in this bad boy here that we're going to have to write down. Just to expand on our ways we can prove triangles congruent. Love that stuff. All right. So we've got some review, right? AE is perpendicular to DE. I know what that means. I know that that gives me a right angle. And I also have AE is perpendicular to AB. Boom. Mr. Allen notices he forgot something. Segment line over DE. Okay. Wonderful so far. I like it. Now, there's something new there. It says AE bisects BD. And you might be saying, well, Mr. Allen, I know what bisecting means. We dealt with that with angles. Correct. We dealt with that with angles. But when a segment bisects another segment, it splits that segment in half. So if AE is bisecting BD, it's splitting BD. That means I get DC, and yeah, BC to be congruent. Okay. I like it. That's exciting stuff. Okay. So we're going to want to write that bad boy down. Let me first make all this maybe a little bit smaller here. And I want to group all that. I think it might be okay to do. Cool. All right. Now let's write down what we have for bisecting. A segment bisector. Segment bisector splits a segment into two congruent segments. So it's kind of like midpoint, but it's just a different wording is a good way of looking at it, okay? Well, that's something that we do want to jot down right here in our notes. So we got all sorts of different theorems, properties, definitions that we've got that we can use in the context of proving triangles congruent. All right, so I've got my right angles, and I know my right angles are congruent. I will write that in my proof. I've got that BC and DC are congruent. I'll write that in my proof because of the segment bisector. It splits into two congruent segments. So I've got a pair of angles, I got a pair of sides. I need something else. Well, right now as it sits, if I've got these two angles and these two sides, another segment is going to give me an angle side-side situation. So what if I actually look at my angles right here? Angle ACB and angle DCE. Those two angles are congruent. Why? Because they are vertical angles, and we know vertical angles are congruent. So I'm going to go ahead and pop down a couple congruent marks. Oops. There we go. I think we're ready to do this proof. We're ready to prove these two triangles congruent. Let's do it. All right. It's a very lazy given that I wrote there. So first off, I know that angle A and angle E, it's nice that I can just write those with single letters because there's no other angle with that vertex of A or E. Angle A and angle E are right angles. I know that from my definition of perpendicular. And if you forget like the shorthand version, you can just say, oh, if it's perpendicular, you get right angles. And I'm totally cool with that. Okay. Now, the other thing, we said that BC is congruent to DC. All right. BC is congruent to DC. How did we know that? We knew it because it was a segment bisector. All right. Or definition of segment bisector is cool too. You can throw a definition in there if you'd like. So I've got a pair of angles, pair of sides. Now I got to get those vertical angles. If you said angle C is congruent to angle C, that's no bueno. There are multiple angles with a vertex of C. So I do have to say angle ACB is congruent to angle ECD. The order in which I list the angle is somewhat important. So I could do ACB or BCA, and it means the same thing. C just has to be in the middle because it is the vertex. I couldn't have like CAB. It wouldn't mean the same angle. Okay? So those guys are congruent because vertical. Oops. Vertical. Oh my goodness, my iPad is slowing down. Let me try writing that again. Oh God. Vertical angles congruent. And now that I got my vertical angles congruent, I've got my triangles congruent. And how are those triangles congruent? It is an angle side. Sitch we got going on. So A CB, and the other one is triangle ECD, angle, angle, side. Awesome. All right, so we got our one new property right over here. Did a proof with it. That's awesome. We're going to do one more proof right now. Alrighty. Uno más proof. So here's what I've got. We've got a parallelogram. ABCD. Okay. Now, we know quite a bit about parallelograms, or we should know quite a bit about parallelograms from our quadrilateral family tree. All right, so there we go. I put them in there from our quadrilateral family tree, or the properties chart, which is located on the website. So I know that my opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent, the consecutive angles are supplementary, and the diagonals bisect each other. Well, I wonder if there's anything I could use here from these to get some congruent triangles. I'm trying to get those two triangles congruent that are in that parallelogram. Well, I did say that my opposite sides are congruent. I also said that my opposite angles are congruent. There's actually a few ways to do this proof. Well, I know that if it's a parallelogram that AD and BC would be congruent, right? I also know that DC and AB would be congruent because they're opposite sides and they're congruent, right? I mean, that's what it says there for a parallelogram. I gave you it's a parallelogram. You can use all of these. So we just use this one right here. I could also say that angle D and angle B would be congruent from this bad boy right here. Cool. Well, that's side, angle, side right there to get those two triangles congruent, isn't it? We're done. Let's write that proof up. And then I'm going to go over a slight change for that one to show that there are a couple ways of doing this. Okay, so I've got AB is congruent to DC, and I also said that AD was congruent to BC. And it was the same reason. If we have a parallelogram, then the two arrows with that, like the double arrow kind of thing like that, that means then. Opposite sides are congruent. Okay, and I can just have both of those in that because it's all it's from the same reason, and it's not like AB being congruent to DC has any bearing on AD and BC being congruent. So I can put them in the same step. And then my next one will be angle D is congruent to angle B. Again, if it's a parallelogram, then in this case it's opposite angles are congruent. Cool. So is that enough to prove my triangle is congruent? Absolutely. So I'm going to have triangle ADC is congruent to triangle CBA. My reason? Side, angle, side. I like it. Now, could I have gone a different direction? Some of you might have thought initially, hey man, what if I just said, so this would be like a separate proof. Okay, I could do steps 1 and 2, but a new step 3 could have been that AC is congruent to itself. And that would be by reflexive property. And then I'd have my triangles congruent, not by side, angle, side, but by side, side, side. And boom, there we go. So again, these are two separate proofs. They start out with the same two steps, step 1 and 2, and then instead of doing the opposite angles, I could say those sides are congruent, the reflexive sides, right? So AC congruent to itself would do side, side, side for those triangles then. Okay? So either one would have been acceptable, totally up to you. It just depends on the person, what they see first. All right. America, freedom, rock and roll.